Okay, good afternoon. So today we are looking at stopping distances, and we're going to look at stopping distances in two different ways. So first of all, we're going to look at how the conditions of the roads and tyres affect stopping distances. So there's a formula regarding how that affects it. Then we're going to look at how your reactions as a driver and the time to actually come to a stop affects braking time as well. So two different ways of looking at how stopping distances happen when you're driving. So starting off with looking at tyres. So tyres are one of the most important part of the cars in ensuring cars are safe and roadworthy. Obviously, they're how the car grips to the road, and if the tyres aren't in good condition, the car won't be able to control itself properly and won't be able to brake properly. So they're a really critical part, obviously, and then the conditions of the road affects how they work as well. So an important test of how safe tyres are is looking at the stopping distance. And there is a formula for it there. So it's D equals 0.35 times S divided by F. And what that means is D is the stopping distance, S is the speed of the car in kilometres per hour, and F is something called the coefficient of friction. That one F is always given to you, so that's very easy. So basically, to work out the stopping distance for tyres, we want to do 0.35 times the speed of the car and divide that by F, the coefficient of friction. Okay. So I've got an example here. I'm saying an icy road has a friction coefficient of 0.1. That's very low. How far does it take for a car to stop if the car is travelling at 15 kilometres per hour? So looking back to the formula at the top, S is 15 and F is 0.1. So we want to do 0.35 times 15 divided by 0.1, and that gives you 52.5 metres. Okay? That's a pretty far distance. So 52.5 metres when you're only going at 15 kilometres per hour, that's pretty far to go. So driving in the ice is really dangerous because of that, because even if you see a hazard, it takes a long time to come to a stop. So basically, when you're driving in the car in ice, you want to be going as slow as you possibly can, while still keeping the engine going. Not a huge issue here in Australia, something I had to deal with back when I lived in the UK. But yeah, if you are ever driving in the ice, as slow as you possibly can. Okay. So that's the stopping distance of tyres. But we also need to look at the stopping distance of a human coming to a halt once they see a hazard. There's a slightly different formula for that. So when we see a hazard, we have to both have time for our brain to process that there's a hazard there, and then time for the car to actually come to a stop. And obviously the car will be moving while you're thinking, and the car will be moving while you're braking. So those things together make up what we call reaction distance and and braking distance. And together, that makes the stopping distance. So I've put there, when there's a hazard, a human must process it and then brake. The distance travelled while the human is thinking is called reaction distance. Okay? The distance that the car moves while it's coming to a stop is the braking distance. And then the reaction distance plus the braking distance makes the stopping distance. So just for an example, let's say you're driving and then you see a kangaroo in the distance, and while you're thinking, it takes you 0.5 seconds and you move 5 metres in that time. So your reaction distance is 5 metres. Once you start braking, your car still moves 16 metres. So your braking distance is 16 metres. So adding that together, the 5 metres plus 16 metres makes 21 metres in total. Okay? So really, just two different ways of working out stopping distance, one more in relation to the human, one more in relation to the tyres of the car. Just a quick reminder, for the tyres, the distance equals 0.35 times the speed divided by the friction coefficient. And for the more human one, the reaction distance plus the braking distance makes the stopping distance. So you have some questions about that, and good luck with them. Okay.